Hi, in this video we'll learn about molecular geometrics and let's learn about something called Vesper theory. It's sounded as Vesper, but it's written as Vesper. Okay, so what's a Vesper theory? So valence shell electron, this is the expansion of Vesper. Valence shell electron pair repulsion. Valence shell electron pair repulsion. So what does that mean? So valence shell is nothing but, so let's say carbon has four electrons in the valence shell. 1, 2, 3, 4. And these electrons do not like to stay in one place or as close to each other as I mean, like they want to stay as far away from each other as possible because there is a repulsion going on between the two electrons. So, but they cannot go loose from carbon either. They have to stay close to carbon, but they have to stay far enough so that they are still attached to carbon. So what is this Vesper theory is used for? It is used to predict geometry of the carbon atoms, geometry. So this is a carbon atom and 4 electrons of a carbon atom, and the electrons are being repelled from each other and they put at a certain distance from each other. So that makes an angle. That makes an angle of separation from each electrons. So this will determine like the geometry. Let's say one electron is far away from this, then it will determine the geometry, the shape of the electron. So let's see how it is done. So we talked about how the electrons repel each other in the valence shell and the bonds that are formed on lone pairs of an atom. They want to get as far away as possible so they don't repel with each other. So there are 3 different types of shapes we'll be discussing. One is the linear shape, repulsion of electrons and bonds caused in between the atoms in a molecule forms the linear structure with 180 degrees, and then we have trigonal planar with 120 degrees and tetrahedral with 109.5 degrees. So this is the linear structure. Let's take an example of carbon dioxide. So if you look at the carbon dioxide, oxygen and carbon dioxide are in a straight line. So if you take the angle measurement between the carbon and oxygen, then that will be 180 degrees. So that 180 degrees here and 180 degrees on the other side. So this will show that the carbon dioxide is in the linear structure. This is how you can determine whether the given molecule is a linear structure. And then we have trigonal structure. Let's take aluminum chloride. So aluminum can form has a 3 plus, so it can bond with the 3 chlorine atoms to make it a stable atom. So if you look at the structure, if you look at the structure, the angle between this chlorine atom and aluminum atom is 120 degrees. The same here. This chlorine atom and here is 120 degrees. This chlorine atom and this aluminum atom is 120 degrees. So if you put each atom 120 degrees apart from aluminum, this forms a trigonal planar structure. Let's take a look at tetrahedral structure. So for tetrahedral structure, we have methane gas. So hydrogens, carbon can form 4 bonds. Can form 4 bonds, but how can these bonds be arranged so that the atoms are not repelling from each other? These atoms are not repelling from each other. So if this hydrogen, the bond between these two bonds, if this bond and this bond are forming an angle, they should be separated with 109.5 degrees. The angle that's formed here is the same, that everything is like 109.5 degrees. So if you well, let me take off all this. So if you take look at this structure, I drew a different projection of the methane structure, which this dark side will show you that hydrogen is facing you, and the dotted line will show you the hydrogen going towards the back. So this will, you can imagine the structure as this, like a simple structure. So each bond should be separated at 109.5 degrees from each other to give it a tetrahedral structure. So if you want to find out whether the given molecule has a tetrahedral structure, then you need to check the angle between these two bonds or in any two bonds and see if it is 109.5 degrees. Thank you so much for watching this video, and I'll come up with more videos and more things to learn. So keep watching my videos. Thank you. Bye.